Hi everyone, what's up? This is Dr. Homer Bob. Welcome to my channel KI Corners. In this lecture, we will study Newton's Raphson method. Why do we use this method, Newton's Raphson method? We use this method to calculate the roots. What is the roots? Okay, let's take example, quadratic equation, which is ax squared plus bx plus c. And we have a formula for the roots, which is equal to x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. So we find two roots. For third and fourth degree equation, this kind of equations, there are also formulas for the roots maybe existed. However, they are extremely complicated. If you go further degree, polynomial, degree, this kind of equations, high degree equations, there is no such formula. And you go transcendental equation, this kind of equations like cos x is equal to x. We cannot find the root. X, with formula. So that's why we use numerical technique. Now we are using numerical technique is Newton's Raphson method. This is another name of Newton's Raphson method. Newton's method, or we know this method with this name, Newton's iteration method. So root, here is in this graph root, our root is 0.0076. Okay, but we want to know more accurate values, so we need to zoom in, and then we see actually real value root in R actually is 0.00762860603. This is kind of like deceiving. Life is not easy. Life is not simple. So we do, for roots, we use iteration method to calculate more accurate values. So that's why we use numerical technique and approximation. Actually, we do, numerical technique. We use numerical technique. Through this technique, numerical technique, we find approximate values. We have to truncate our iteration method, or we have to stop some at one time. And this is time, we have to decide, we have to give conditions. So if we find accuracy like our error like around about 0.000000 kind of 001, and then this is our accurate value. What I mean, suppose our decimal places is approximated and accurate with 6 or more decimal places. If you find 8 decimal, more than good. So in this method, Newton's Raphson method, we have to do first approximation. First approximation value is x1. We give x1, and through Newton's Raphson method, we find another approximation value. Here is x2. We apply and we do more iteration. We find x1, x2, x3, x4, and so on. 2 we stop at accuracy of is our real root is, true value is r, that is root, but we like approximated, approximated value we find through this technique, this Raphson method. So consider the tangent line, that is L, to the curve function y0 f of x at point x1, and look at this tangent line. You see intercept point, that is x2. We find another approximation value. This is second approximation value, and we do like the same way at x2. We point out x2 f of x2, and then we take tangent line at x2, and you see we find another approximation value, which is x3, and see we have to know now we're going to drive Newton's Raphson formula. So we know, we are familiar with point slope formula, that is y minus y1 is equal to m times x minus x1. So we look here, y minus f of x1 is equal to f prime x1 times x minus x1. Now we considering point slope formula, and then what we do, we're going to set value y is equal to 0, and then x is equal to x2. In this equation we see second approximation value here. Why we do y is equal to 0? We know at intercept point y always is 0. So this is our second approximation value. We are approximating to r, and then now third approximation, we do repetition, and similarly x3 is equal to x2 minus f of x2 divided by f prime x2. We do like continuously, we find more approximation value, more closer to r. See, we generalize for the formula, that is Newton's Raphson formula, xn plus 1 is equal to xn minus f of xn divided by f prime xn. So now we take example. So we have equation x cubed minus 2x minus 5 is equal to 0. Now we're going to calculate the value of x. So we use we guess first for the approximate, we take we suppose value of x1 is 2 here, and then we find another approximation value which is x2, then we plug in this equation, and then we find another approximation value for x3. We do like we use this formula. Okay, let's see, we have we make it equation to function x cubed minus f of x cubed minus 2x minus 5 is equal to f of x, and then we take derivative of this function. A derivative of x cubed, we know 3x squared minus 2x, derivative of minus 2x is minus 2, derivative of minus 5 is 0 because 5 is constant. So, and we apply y, I consider a first approximation value is equal to 2. So see here, we plug in x equal to 1 in this function, f of x is equal to x2 minus 2x minus 5. If we plug in x equal to 1, then we find f of 1 is minus 6, and we plug in f of 3 as in the same equation, same function, f of 3 is equal to 16. So you see value is negative and positive, so there must be in between these values, must be the root existed. So that's why I consider 2. You can consider 2.1, 2.5, but I always consider simple. I make it always simple. I wanted to make everything simple. but actually it's very hard, do like through simple way, start from simple way, but try our best. We have to try our best. Anyway, so I use Newton's Raphson formula. Xn plus 1 is equal to xn minus f of xn divided by f prime xn. So we plug in value of xn. X1 is 2, and then we plug in, then we find second approximation value, that is we have find x2 is equal to 2.1, and we plug in again x2, and then we find x3, and I'm using this formula we have studied earlier. So I'm sorry. So the rule of thumb is generally used is that we can stop when successive approximations xn plus 1 agree to 8 decimal places. But sometimes we stop for like 6 decimal places, 4 decimal places. It's still, it depends on you. So now we have find approximation value is 2.0946. This is root for this equation. Okay, first root. Okay. And then second, third roots we can calculate through quadratic equations. Anyway, so we take another example, 6 root of 2. Wow. We are familiar like square root of 2 is 1.414, but now we are calculating 6 root. So how? So I take I suppose x is equal to 6 square root. So we're taking power 6 on both sides, and then see x power 6 minus 2 is equal to 0, or x power 6 is equal to 2. Okay, and then we make it in function. F of x is equal to x power 6 minus 2 here, and then we take derivative and just we plug in here in this formula. Xn plus 1 is equal to xn minus f of xn divided by f prime xn. We consider here for the approximation value is 1. Why this question? Square root of 2 is 1.414. So around 1. So always try to guess your simple. Don't try to guess decimal places. You can consider 1.2, but now I'm taking a first approximation value is x1, and then plug in here, and then similarly we do like for x3, for x4, x5, x6 still, and now we're going to stop. Why? See, for as x5 and x6 agree to 8 decimal places. You see 0.12246,205 here, 0.12246,205. So we're going to stop, and then 6 root of 2 is equal to 1.12246,205. This is approximate value. Less error here. Okay, now we have computed 6 root of 2, and then you check on calculator, you find like this, like same answer. So same answer. Now example, last example, third example in this lecture, find the roots of this equation. This is transcendental equation, cos x is equal to x. So we need to correct value, correct to 6 decimal places value. So we write this equation, cos x minus x is equal to 0, and then we make it into function. F of x is equal to cos x minus x, and then derivative of this function. We plug in Newton's Raphson method. Xn plus 1 is equal to xn minus f of x divided by f prime x, and we find first approximation value, x2, and then we use another step for a second approximation value. We take n is equal to 2, and we find third approximation value, that is x equal to 3. So now we need to find we need to take supposition, first approximation value, here again x1 is equal to 1, maximum value, cos 0 is 1. Always, maximum value for cos, for sine is equal to 1, right? So, just kind of guessing, So, I consider first approximation value is 1. We plug in this equation, x1 is equal to 1. So, we plug in here, we find x2 is equal to 0.75036,387, this value, and plug in this equation for x3, and then we find this answer, and this we plug in x3 here in xn, then find x4, and similarly for x5 is c, as you see here, x4 and x5 agree to still decimal places, 0.73908,513. So we stop it. We conclude that the root of the equation correct to 6 decimal places is 0.7390851. I'm sorry, 0.73908. This is 6 decimal places. So this answer you plug in, we check the value really is accurate. Cos this value 0.739085 we plug in here, and C is equal to x cos 0.73 equivalent to 0.73 this answer. So you check on calculator. Anyway, for now I'm going to closing my lecture. So thank you. Bye bye everyone. Please don't forget to subscribe my channel. Thanks for your help. This is my helping from your side. Really, I need a subscription for next videos. I want to update my video channels. Bye bye.
किससे बात कर रहे थे?